Hello, good morning. Now we will discuss this conformational analysis of ethane and butane. Before this, what is meant by conformations? Conformations are the different spatial arrangements of molecule that are generated by rotation of carbon-carbon single bond. And if we form this, sometimes these are called as conformers or rotamers, or these are called as conformational isomers of each other. This is a representation of ethane in the form of wedge. This is showers, this is front carbon, and this one is the backside carbon. This is Newman projection. This is Newman, which conformation it is? Staggered conformation, not eclipsed. It is Newman projection. Showers having two types of conformation. One is ethane and ethane eclipsed and ethane staggered conformation. This is what is meant by torsional angle. It is angle between two bonds originating from the different atoms in a Newman projection. Means it is angle between these two hydrogen atoms having a 0 degree. Means these atoms are originating from the different atoms, and the angle is called as a dihedral angle or torsional angle between these two. It is in case of it is eclipse conformation, torsional angle is 0. When we rotate this carbon-carbon single bond with 60 degree, it form a gauge conformation. Again we rotate this with 180 degree, it form a anti, means it is anti conformation, means it is a staggered conformation. It is eclipse, and this one is the staggered conformation of ethane. When this is the showers representation of two, it is eclipse, and this one is the staggered. These hydrogen atoms are, in case of eclipse conformations, are back to each other. This one is above the plane and another one is below the plane in case of staggered conformation. These hydrogen atoms are in the same plane. That's why this is having a more energy and less stability, which will be represented by this Newman projection. These two hydrogen atoms having 0 degree torsional angle. So this one is 180 degree, isn't it? So that's why these are more stable. It is 60 degree staggered conformation is more stable than eclipse conformation. Conformations of this ethane by representing this energy profile diagram. Here is the degree of rotation with potential energy. This is 0 potential energy. 0 degree rotation, it is eclipse conformation of ethane, means these are 0 degree angle of torsional angle. When we rotate with 60 degree, it form what? Like this. It rotate with 60 degree, it form a gauge conformation, isn't it? So this is the gauge conformation. This one is again eclipsed with higher energy than the 60 degree. It is 120 degree. Again we rotate this carbon-carbon single bond, it form 180 degree with degree of rotation. It is staggered conformation again is formed. It is called as anti. It is gauge conformation, means staggered having two types. One is gauge, this one is again gauge, and this is anti-staggered conformation. These are the eclipse conformation. Again we rotate with 240, it form eclipsed. Again 300, it is gauge conformation, staggered. It is more stable than this. This one is again 360 degree having eclipse conformation, least stable than the staggered conformation. Means 0, 120, 240 and 360. These are the eclipse conformation, rotation of degree. These are the eclipse, and this three are the staggered conformation. One is anti, and this two are the gauge conformations. These are the gauge conformations. So these are more stable than this eclipse conformation, having less energy than eclipse conformation. So the question is, why is the eclipse conformation higher energy than the staggered conformation? The first reason is there is some steric repulsion between hydrogen atoms in the eclipse conformation that is reduced in staggered conformation. In eclipse conformation, the electron cloud of carbon and hydrogen bonds are most nearer, and thus their repulsion increases. Due to this repulsion or repulsive forces, it creates a torsional strain in the molecule. If the more is the strain, more will be the internal energy. If more will be the internal energy, less is the stability. That's why this eclipse conformation is less stable than staggered conformation, having a more energy due to this steric repulsion between carbon and hydrogen bonds. These are the nearer, and thus the repulsion is increases. Isn't it? So next one is N-butane conformation. It is 4-carbon alkane derived from ethane, in which the one hydrogen atom on each carbon is substituted by methyl group. When this ethane means this 2 carbon atoms, this is ethane. When we replace one hydrogen with methyl, this is a methyl, this one is again methyl. So this is called as a N-butane chain, isn't it? This is isobutane. We will consider this N-butane. N-butane has more than one staggered and eclipse conformation, and staggering or eclipsing in the conformations may be partial or complete conformation. This is the energy profile diagram of this. Before this, this is a eclipse having syn periplanar and anticlinal conformations in case of N-butane, because the hydrogen atom is substituted with methyl functional group or methyl group. The staggered conformation having two conformers, that is synclinal is called as gauge and antiperiplanar. No doubt the staggered is more stable than the eclipse conformation. Means, for example, when we consider this is a syn periplanar, 0 degree, means this again methyl groups are having a 0 degree torsional angle. When we rotate this methyl group with 60 degree, it form energy 0.9 kilocalorie per mole. This conformation is called as synclinal or gauge conformation. Again we rotate with 120 degree. This one is form anticlinal, means having a more energy than this anticlinal. Again we rotate with 180 degree of carbon-carbon single bond. This is antiperiplanar, means this is totally these two methyl groups are away from each other. There is no steric repulsion between this two methyl groups, so it is more stable than out of this antiperiplanar. Again we rotate this with up to 240 degree. This methyl group is here. This is called as anticlinal, like this anticlinal, having 3.6 kilocalorie per mole. Again we rotate this with 300 degree. It form 0.9 kilocalorie per mole. This is synclinal or gauge conformations. Means this N-butane having the synclinal and gauge, 2 synclinal, 2 anticlinal, 1 antiperiplanar and 1 periplanar. Means out of this, 1 antiperiplanar is more stable than this all. Means antiperiplanar is more stable than this. Syn periplanar, again energy is increases up to 360 degree. So this is a dihedral angle in degrees, and relative energy kilocalorie per mole, 4.5 kilocalorie per mole. This is 3.6. So this is 0 relative energy. That's why it is more stable than all these conformations of N-butane. So again I repeating this, eclipse conformations are two syn periplanar like this. Syn periplanar, these two are syn periplanar, having a dihedral angle 0 and 360 degree, having a maximum energy. But the anticlinal, these anticlinals are again eclipse. These are the eclipse, but the energy is 3.6. It is 120 and 240. Energy is lower but not least, isn't it? The staggered conformation having two again synclinal or gauge conformation having 0.9 kilocalorie per mole. These are the synclinal and gauge conformations having 0.9 kilocalorie per mole. And the anti-periplanar conformation, dihedral angle is 180, have least internal energy than other. It is anti-periplanar. It is more stable than all ethane conformations. So this is regarding the ethane conformations. So energy difference and stability and potential energy changes in the conformation is due to steric repulsion observed in different conformations. In syn periplanar conformations on N-butane, methyl group are most nearer to each other, causes steric repulsion and reach to the most highest energy state 4.5 kilocalorie. In anticlinal conformation, it causes steric repulsion between methyl group and hydrogen atom. But in case of anti-periplanar conformation, all atoms are far apart, especially methyl groups, because it least steric repulsion and reach to most lowest energy state, that means most stable conformation of N-butane. Due to the steric repulsion, this form least steric repulsion, it form more stable conformation. That's why anti-periplanar is more stable conformer of N-butane than all, that is syn periplanar and anticlinal conformer. This is regarding ethane and N-butane conformations.